point a couple of things out. And I really shouldn't, because attendance to the lab class, to the lecture is mandatory, and the fact that you may have had a lie-in for whatever reason doesn't mean I should have to keep repeating my class. However, that said, I will go over a couple of points right now, because I don't particularly want half the class to end up failing. When I send you a message on Moodle and it says it is really, 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 really important to attend the lecture, it doesn't mean, oh well, I'll just turn the alarm off and go back to sleep again, alright? It means that it's important. It's just like when lecturers say, we're going to do a revision class. They're not going to talk about swimming lessons for under 5-year-olds in Dubai, and they're not going to talk about how to make an ice cream instead of going to the local shop. They're going to talk about the subject, and they're going to talk about what's on the textbook. Okay? So that's the last kind of wake up call I'm going to say. I'm going to go to the notes section first of all. You'll also notice that there is an assignment now on Moodle, which I went over in great detail this morning in the lab. The assignment, wrong one, that's the result, sorry. The assignment is under the assessment section, and it is right there. I'll move it up. The project is worth a lot of marks. It's worth 40 marks. And after today's lecture and today's class, you should be able to do the first part, which is draw the reinforced slab concrete. You should be able to do the reinforcing bar schedule and complete some of the quantities table. Okay? So quite a few marks just after today's class. You'll also note that hand-in time and date is the 8th. And please, please, please do not start it on the last weekend. I don't think I could finish it in the last weekend. So what you're going to be drawing up is detailed in the 3D sketch. Sorry, it's shown in the 3D sketch. It's detailed in the 2 sectional drawings. There it is there. You're going to be only drawing up the slab, the orange bit, from the plan view with the reinforcing bars in it. In the notes today, I went over and pointed out a lot of things that you need to revise for the test. I also pointed out a lot of things that could be added to your notes on your drawings, and I showed you a couple of things on the whiteboard. And we talked about at the very end how we represent the bars on reinforcing, and I'll just kind of skip straight to the end of that section of week 8 notes. So we're not doing too much more extra revision than we need to. The very end of week 8 notes, we looked at how we represented the wall of a retaining wall in a drawing format. And there it is there. And just to remind you, when you're drawing the bars, you don't have to draw every single one. In fact, you'll get marked completely wrong if you do. One bar is drawn just like what Ingrid taught you, and it's the width of the bar is the diameter. There is always a cover section, whether it be 40, 50, 30 mils, depends on what the assignment said. And the bars are pressed hard against that cover section. So for each bar, see the thick bar there? You draw a line that's got a P line that's got the width, and the width is determined by that number there. So that'll be 16 mil wide. You do 2 delimitators, which are one at the top and one at the bottom. They're approximately 3 or 4 times, 3, 4, 5 times the diameter and length. That's roughly what they should look like. And you do an arrow going from right through from one delimitator to the other. Where it touches the bar, in order to connect that bar to those delimitators, we do a circle twice the diameter of the bar. And on top of the bar we put the important information which we went over in the lecture this morning. Okay? Notice the number of bars there and the spacing, the number being 8, the spacing being 250 on the horizontal one. Now the last part, the EF, each face, when you have a retaining wall standing up, we have NF, near face, if the reinforcing's on the front. If it's at the back, it's called far face, FF. If it's down the bottom of the retaining wall, if it's the top of the slab, it's top. If it's the bottom of the slab, it's bottom. We also talked about the mark number, this one here, and that is the steely will number the bars according to where they are on the building or the job altogether. So if it's the bottom of the wall, they'll start off down there at number 1, 2, 3, 4, 5, and if it's further up on the retaining wall or the building or the bridge, it'll start having higher numbers, 80, 90, 100, whatever. That way, everything's arranged on site according to how they're going to build it, because you always start from the foundations up. Okay. So that's the notes in a nutshell. You're going to have to read through those and ask anybody that was in the class what we got about this morning. Let's get to the crux of today's lab class, which is explaining to you a class example. So I'm going to make that available now. So for those that are on computers, they've got the computers logged in. Regen everything, and you should get this class exercise. Okay, so the class exercise is somehow bounced out of the movie. So under week 8, we'll click on class exercise again, and here it is. We've got exercise 1 and 2. We're going to go over number 1 in class. You right there? Girlfriend? I'm happy to answer it for you next time if you like. You might be lucky. You might not be too. Find out you're
Window
a 60-year-old mate.
window.
Alright, back to the seriousness. Okay. The first thing you're going to have to do in your assignment is a reinforcing bar schedule, which you can see down the bottom there. Looks something like that. So I'm actually going to copy that onto my whiteboard here. So for those that are seated sort of in this region, well done. You're going to see the answer come before your eyes. For those that are seated over there, well done. I'm going to be working through it bit by bit over there. Now is that Ingrid stuff? We wouldn't want to rub that out. Then again, yeah, I like to live dangerously. I will, I'll get rid of whatever's there. No, it's been, it's already been dealt to. Well, there's a trick to this. If you draw over what someone's got on the board, it rubs off. Did you know that? I found that out. Yeah. There we are. So over here I'm going to do my workings, and over there I'm going to put the answer. So basically you can take a photo of everything at the end if you like, or you can write down things as I'm doing it, up to you. Well, that didn't work, did it? What about a good old fashioned water? Well, that's oh, that's probably a clean enough board for me to carry on doing what I was going to do. Alright, so up there you see that we have the location, the bar mark, the number of barley, mass, weight and sketch. Now here's a question, and those that were in the lecture this morning are probably going to have the best chance of answering it. Why are we trying to find the weight and the total weight down the bottom as well? Anybody like to have a crack? Yeah.
To know how much it's going to cost.
Yeah, too right, 100%. It's a shame I didn't say about the half mark, eh? No, that's a half mark for the gentleman at the back. As long as he emails me before 12 o'clock tonight, and he's on his email already, didn't take long. Okay, so it's exactly right, and it's how we price the reinforcing. So there'll be a price per weight, per kilogram of the reinforcing, and as engineers we need to know a rough idea of the job and the cost. So yeah, you'll end up having to get a total weight, and then you can apply that to a cost overall. Of course, there's also labour, which has to factor into everything as well. Now, before I start this, which I'm just about ready to go, I need to explain that in the engineering world there are construction companies, and there are also consultancies. Now that to second language students that sounds like the same word. It's not, it's very, very different. Construction companies, they do the building. So often they'll take the plans from the consultancies and they'll build it. A bit like an architect and then a builder or a chippy or whatever they call it. All right. Sometimes construction companies have their own, they employ their own engineers and their own, and they do the design and build. That's called a design and build job. Whereas quite a lot of times in Auckland, a construction company takes the plans. They might have one engineer working for them who interprets the plans, and they'll have the builders, etc., that build it. And of course, trucks and diggers and rollers and all those other things as well. Reinforcing companies that do the reinforcing, sometimes they will do their own reinforcing bar schedules, in which case the consultants, all you'll put on your drawings is D16s, 16mm bar, D16s at 300 centres. Done. Your job's done. You've done the design. You're not cared about how it fits in the concrete. That's all you do, and you move on to your next job. obviously you're not going to get paid much. The reinforcing guys will have an engineer working for them, or a engineering technician, and they will work everything out like you're doing now. So it's a little bit confusing in that the way how it operates in New Zealand. Sometimes consultancies do this, sometimes construction companies do this. All right. So it just depends where you end up working, but it's really good to have a working knowledge of how it all works. We were working for the Saudis over in England, and the Saudi Arabians didn't want to have a bar of it. It's a little pun on that one, by the way. So they said, you guys do it. So we did all of that. They didn't have the engineers or anyone that wanted to do that side of things over there. So we did the whole lot and handed it over, and somebody else built it over in Saudi Arabia. I have worked for consultancies here in Auckland, and the only thing they ever do is put D16s or D12s at 250 cents. Done. Revit, when it draws reinforcing, it doesn't really give a decent bar schedule, and it also doesn't really do reinforcing to a great deal of detail. So it is possible that you're going to have to do proper detailed reinforcing drawings in a consultancy in New Zealand, at least until ChatGPT or something ends up working out how to do it. And this is one thing that students find really hard to cheat in, because you can't go, hey Google, show me how to do this. It's kind of a skill that I'm teaching you that you're going to have to try and get your head around. That's why it's important to turn up to today's class. Right, so I'm going to turn around and I'm going to start drawing that sheet up here. So what it is it is a location. And then the next one is, of course, the bar mark, which is made up of the diameter and a number. The next one is the bar length. Oh, sorry, number off. Number off is a fancy way of just saying how many. We're going to work that out. And I can guarantee you, when I first start doing it, you're all going to get it wrong. Bar length, hopefully you'll prove me wrong. Bar length. And then after that we have the mass per metre and the weight.